So here we're going to take a look at an alternative, a slightly more advanced setup for the player platform control. We're going to use variables in order to kind of control the user input and the output of the platform. Now we're going to just jump right in. We're going to take a deeper dive into variables, kind of a slower, more methodic approach to variables in our next project. But I wanted to just jump in for those of you that might have been exposed to variables or who can pick up the concept very quickly. It's pretty simple, pretty straightforward. It can be abstract if you've never thought in terms of variables, but it would be helpful for you to give this a shot. Before we jump into the player control, I'll just give you a really quick demo of one example of a variable, use of variables. It's not inherent to Playmaker, it's inherent to the game engine, and again, Playmaker behind the scenes is just using C# scripts, so we're really using stuff that's available through scripting and through the Unity engine. In order to demonstrate this, I'm going to set up a very simple rotation script just like we did in previous presentations, and this is going to be my test cube, so I'm going to name this appropriately even though I'll delete it very quickly. I'm going to add a state machine like I did in the previous presentation, back when we were talking about the rotation scripting. And I'm going to do a simple rotate command on state 1. So I'm going to state 1 selected of my new state machine. I'm going to select rotate, hit the return key. So this time around, I'm going to rotate around the y-axis. In previous presentation and previous implementations, we just took, say, the y angle and we changed the value to a positive value, and we told it per second every frame, and now it will rotate every frame. A little slow. Let me bump that up so we can see this a little bit more dramatically. We'll do 45 degrees per second so we can see that rotating. Now, this is a hard value, meaning that once we type in the value, we're stuck with that value. We can't change it. But if we start using variables, variables are data containers. They're factors or bits of data that can change over time based on user input, based on game engine input, based on a lot of different factors. And so I'm going to toggle this y angle back to variable, which is when it says none. And so just like transition events and other bits of data inside Playmaker, we don't have any variables that are set up to use, so we need to create a new variable. We're going to avoid global variables for now. We'll talk about the difference later, but when in doubt, just use a new variable or a local variable. So I'm going to create a new variable. Now there are some rules in creating variable names that we want to adhere to, and if we don't follow these rules, we could break our mechanic, we could break our game. We don't want to use anything that the Unity game engine would interpret as kind of a proprietary command or naming convention. And the way that we can avoid that is we can always name a variable starting with lowercase, always stick to letters, and don't include spaces or any characters that aren't letters. So in this case, I'm just going to call this y underscore rotation, or I could use this, different kinds of naming conventions, but I'm not using a space. I'm using an underscore when I want a visual space. I can use capital letters as long as it's not the first letter in the sequence. So in this case, I might choose Y rotation, or I might shorthand this to YROT, but I'll call this Y underscore rotation for now, just to include both of those conventions, and I'm going to create the variable. Now, when you create a variable, instead of having a hard value in here, it's going to show you the name of the variable, and this is the container that contains data. And by default, the variable is going to be either empty or 0. We'll talk about the different variable types in the next project, but for now we've just created this variable, and we can see the variable because we're in the state machine that contains the variable. If we go to the Variables tab, we can see that we have a new variable. This variable is listed by its title. It's being used one time, and then it shows us the type of data that it is. Now, we'll discuss all the different types of data later, but as long as you're using the state and the action pull-down menu to create your variables, it'll create the appropriate variable type. There's different variable types, and they need to be used in appropriate ways, and so this is a way to ensure that we're getting the right variable type. We happen to need a float variable, which is a floating point, because we're talking about rotation. and therefore we can use positive and negative decimal numbered values. Once we select this variable, you can see that the value is set to 0. We can change that. But right now, if we hit play, it's not going to rotate because it's rotate based on 0. I'll go back to my state, and I can see that it's rotating at 0, or I know that it's rotating at 0. If I go back to variables, I select the variable and I change its value. I'll change this, say, to 50, and I go back to my state and hit the play button. You can see that starts to rotate. Now, it's just using the Y rotation, but we happen to set that value to 50. Once we start using variables, we want to make sure that our debug checkbox is turned on at the bottom of the state window. And this will show us the value of a variable underneath its variable field, so we can see that this is 50. Can't change it right here. And plus, we're in play mode. I'll toggle that button, but my debug is turned on, and I'll leave it on for the rest of the time in this class. Okay, so I see the actual value. So if I go to variables, I'll select that variable, and I'll say 100, and I'll go back to state, and I'll hit play. Now I can see it's rotating at a rate of 100. Now, that you might ask yourself, what's the value in that? Because it's seems redundant. It's a little bit quicker even just to key in that value. But this is a dynamic value. It can change based on things like user input. It can be changed based over time. We can use some math equations to influence the value of this depending on what's going on inside the game scene. We can get some game engine feedback. We can do things like, okay, if the player picks up a power-up, we can add to this value of rotation to increase its speed. So because this is a variable value, it's something that can change over time based on user input or game engine input. This is a very powerful thing. Okay, so again, if I want to repeat that process and create a new variable for the X angle, you'll see that I do have the Y rotation variable available, and I could use that. So now I'm rotating at 100 along the X and 100 along the Y because it's referencing the same variable container. If I change the variable, say back to 50, and I go back to my state, you can see that it's updating that value in both places. So it's very useful and user-friendly, and it's also dynamic. We can change it. Okay, but of course we can have different variables. So if I want to create a new variable for the Z rotation, I could do that, and now I can go to variables and select it and change this to some kind of value. Okay, now we can also initialize these values and these variables as we change different states, and again, with game interaction, which we'll do in a future presentation, but I just wanted to share with you the basic concept of variables. Now I'm going to implement this. I'm going to get rid of my test cube. I'm going to take the player one platform. I'm going to keep it because this is working. It's working in the way that I want to, in a very simple way. My state machine kind of looks like a spider, and that's okay. I'm going to Command D to duplicate the entire game object. So I have player one instance or copy one. I'm going to change this to player two. I'm going to go back to player one, and I'm going to disable that game object. I'll go back to player two, and just so that, in case I want a visual cue to let me know that I'm working on a different platform here, maybe I'll even take the blue. I'll just keep the name, but I'll make it maybe a little bit darker. I'll shift the color a little bit. I don't know. Let's make it. What should we make it? Let's kind of go into the orange realm here, and I'll just change that platform color. So oops, Command Z to undo that. Don't want to do that. We'll drag this over and drop it on the model. There we go. So I know that I'm definitely looking at player two. If I flip on player one, I'll even move that off to the side. I have player two, and in fact, because I've duplicated that right now, they're going to borrow the same input. So I have a little different player scheme going. So I got, with a simple duplicate, I got two platforms, so I got a little different gameplay. If I want to experiment with that, that'll work. But what I'm most interested is I'm going to turn off player one, go back to player two, and I'm going to remove this entire state machine. Going to right-click, remove component. Don't want it. And I'm going to set up just a slightly more advanced control. I'm going to right click and add a state machine. We're going to go through this really quickly. I'll come back and take a deeper dive into this, but there were a few questions about how to control this and how we might want to control a little bit more sophisticated, in a more sophisticated way. So I'm going to call this state player movement. Try that again, player movement. And player movement, or moment, I'll correct that typo later, is going to be a one-state state machine, and the input that we're going to capture is a get access vector. I'll double click and get access vector. What get access vector is doing is getting some inputs from the Unity game engine that are already mapped. The horizontal and vertical axes by default are mapped to both the AWSD keys. So A and D are mapped to the horizontal input. The vertical axis is mapped to WS. It's also mapped to the arrow keys in the keyboard. So up down arrow is mapped to vertical, left right is mapped to horizontal, and we'll see the result of that in just a minute. But also the basic input for gamepads are mapped to horizontal and vertical input. We'll take a deeper dive into mapping inputs in different ways to get user input. In previous presentations, we were explicitly looking for a key. Now we're effectively looking for a button, or in this case, an axis. So these are kind of variable inputs. So we can map to different kinds of controllers, like VR controllers, to touch screens, and by default, these are mapped to the AWSD and arrow keys and the D-pad of a controller. Okay, so we're getting input from the user, and we'll see the result of this in just a minute. But in order to capture the user input, we need to store it in a vector, and that's why this field is red, because it's required to use a variable to work. So I'm going to create a new variable, and this is going to be, I'll just call this movement or move input, or player input. We'll call this move input for now. Okay, now because I have debug turned on, you can see that it's storing values. The values are all set to 0, and this is a vector 3. It's X, Y, and Z. I'm gonna hit the play button just so you see the input here. I'm gonna roll my mouse over the game scene window, and I'm gonna press my A and D keys. And when I do, pay attention to what happens down here in the store vector. I'm pressing the A key, and I can see that first value goes to -1. Okay, I'm gonna press the D key, or the right key, and I see that the value goes to +1. So we're operating on a scale of -1, +1, in a vector 3, and whenever we see 3 values together, it's a safe bet to assume that this is X, next value set is Y, and Z, just like when we scripted that rotation. So by default, our horizontal input is mapped to X. So left, right, I can see that value moving. If I use the W key and the S key, I can see that third value changing from -1 to +1. So we're still operating on a range, which is indicated by a multiplier here of 1. Okay, so our vertical input, and I could use the arrow keys. I'll switch over to my arrow keys. This is my left arrow key, right arrow key, up arrow key, down arrow key, positive to -1. We're mapping to the plane of X, Z. First value is X, second value is Y, third value is Z, which is exactly what we want, because now if I hold down the AWSD keys and move in a forward, backward direction, we're mapped to X, which is horizontal, left and right. Our vertical is mapped to forward, backward, okay, which is good. So now I'll toggle the play button so that this change takes effect. All we did was add a get access vector. We've captured the user input, which we're getting. Now I'm going to go down to my transform, translate, same thing that I used before. And rather than using hard values for X, Y, and Z, I'm going to use vector 3 information, which we're capturing from the user input here. So I'm going to go to vector 3. I'm going to borrow the move input. So we're capturing it with the get access based on the user input, and then we're using it to translate our game object here. I'll hit the play button. It'll move very slow, but we have left, right, forward, and backwards. Okay, and it's all happening in one state. We can see that these values are updating because we have debug checked. That's why we can see those. And if we want this to be a little bit more peppy, to move a little bit faster, we would use this multiplier. So the multiplier is taking the user input, the -1 to +1 scale. I'll bump that up to 5. Now this scale of the user input is going to go from -5 to +5, giving us a much snappier result. Okay, so now I have 5. And this solves a lot of problems because now we're not changing states in this case. We're doing everything in one state, which is good. Okay, even though I can't play the game. I'm horrible at it. We're getting that user input. Okay, so that state machine is now controlling all of the movement. So give that a shot. We'll take, again, a slower, kind of more methodic approach to variables, but there's going to be no substitute for experience and just trying things, making mistakes, and you know, if we break this and this gets out of control, or we get some kind of error, just right-click and either remove the component or take the whole game object, delete it, and try it again. So that'll wrap up this exercise. So come up with some kind of solution. Don't forget all the stuff that we covered in the Gravity Lab, and come up with some basic gameplay solutions. Post any questions that you have in the discussion board. I don't mind continuing to respond with tips and tricks, but I think we have everything that we need to know to do just a really simple mechanic. And in the next project that we'll work on, it'll be more comprehensive, and we'll take a more methodic approach to some of the concepts of game mechanics and managing some of these game systems. So have fun with it. I look forward to seeing your work, and contact me if you have any questions.